What's the coordinate plane to you? Any idea? Anybody? Yeah, coordinate plane is this right over here, right? Okay. So if we look at this right here and we talk about the coordinate plane, this is what we're talking about. So what do I call the yellow line and the green line?
X and Y.
X and Y what? What else besides the X and Y? X blank or Y blank?
Axis.
Axis, exactly right. Okay? So which one's which? The green one is the X and the yellow one is the Y. Okay? I'm kind of a stickler for this. I'm kind of really strict about this. You got to make sure that you put numbers on your coordinate plane whenever you're doing this. So find some graph paper. If you don't have graph paper, I'd get some. Hey, it's I think $1 for a package at Walmart. All of you chip in 10 cents and somebody buy one package and spread it around. Because you won't go through a whole package. Okay? But this is my coordinate plane. When you do this, draw straight lines by using a ruler. There's a stack of rulers right over there in that little tub. Right here. Okay, so every time that you come into class, you need a ruler, there's a bunch of them right there. Okay. The other thing is you need to put down numbers on your axes. Positive, positive, negative, negative. You need to show that you understand where the numbers go. Okay? So where does my coordinate plane start? It starts right here in the middle, right? And right here in the middle, we call what? What is this point right there that is right in the middle? Anybody know? This is called the origin. Ever heard that? And so why do we use a coordinate plane, or what do we use? In this, we develop ordered pairs. Okay? And those ordered pairs, again, are going to use the two axes that you talked about. This is my x-axis. This is my y-axis. Okay? The x-axis is always going to go right and left. So it's going to be right, positive numbers, left, negative numbers. And in my y-axis, it's always going to go up or down. So up is positive, down is negative every single time. So this develops then something called ordered pairs, which we're going to put into parentheses. And inside my ordered pairs, I'm always going to have an x and a y. The x always has to come first. Okay? Everybody okay with all that stuff? From there then, did you notice when we drew the two main axes, the green line and the yellow line? It basically split my coordinate plane into 4 different sections, right? You know what those sections are called? Each section is called a quadrant. Okay? Now realize, when I draw this yellow line and I draw this green line, they go on into infinity and negative infinity. What's that mean? They go on forever. Exactly right. So, even though that we kind of can see this little quadrant right up here, because it's limited by how big mine really was, realize that it goes on into forever. Okay? So quadrants, because it's 4, that's what quad means, right? That's why we call it quadrants. They are named by 1, 2, 3, and 4. Where do we start with quadrant 1, do you think? Which one of these do you think is quadrant 1? Top left. Anybody else? No more guesses? Top right is number 1. Here's the key. When you write quadrants, you need to write as Roman numerals. You all know what Roman numerals are? Basically just kind of letters as numbers, right? So what's the Roman numeral for 1? I, right? So here's 1 up here in the right-hand corner. So where do you think 2 is? To the left or down? Try again. To the left. 2, 3, down here. And then what is 4 as a Roman numeral? IV. Why is it IV? 1 minus 5. Exactly right. Okay? So there's my coordinate plane. Now, on the quiz, on the test, on your homework, you need to make sure that you write them as Roman numerals. If you do not write them as Roman numerals, you write them as regular numbers, you miss half off. Okay? So, here's another thing though. What happens if they ask me to name this dot, or that point, and they ask me what quadrant this one is particularly in? Where is that dot right there? When that dot is on the green line, what what quadrant would you say that dot is in? What do you think? 2? Anybody else? Is it really in quadrant 2 though? Is it in quadrant 3? No. So anytime, right? Here's our part of our notes, I guess we could say. Anytime that you have a point on an axis, so this deals with quadrants. If a point is on an axis, okay, you either say there is none or x or y axis when they ask you what quadrant it is in. Okay? So you either say none or name a specific axis that it's actually on. Don't say, like in this one back here, don't say, well, it's between 2 and 3. Yeah, it is, but we would rather have that as an answer. None or the actual axis. Okay? So, from there then we again come back and we can talk about ordered pairs. These could also be called coordinates. So what are the coordinates of the particular point? And ordered pairs, again, as we showed over there, is always going to be an x and a y. The x's always have to come first. And these are going to really name a point on the coordinate plane. So if there's a specific dot on there and they ask you, well, what is that? You would go and find out where it's at and write that as an ordered pair. Now, not only do I do that though, I also name the point by a capital letter. Or if they give you a capital letter at the beginning, that's what you would use to show everybody on your coordinate plane. So you would put a dot down there and you would say, well, this is N or K or whatever. Okay? But that's how you kind of signify between the two different ones. And then again, remember, for whatever reason this bothers some people, but my x always comes first, so I'm going to go right or left first, and then I'm going to go up or down, and I'm going to put my dot down. Okay? And then I put a point under a dot, and then I put the capital letter that they tell me. And most of the time they'll tell you that. Okay? So, let's look at one of these, or some of these. So, for instance now, if they tell me, I'm going to erase this so I have some room. So if they say that the first problem is K, and we're going to name or put K at 3, 4, and then we have P at 0, 2, and we have D at 5, 3. So even though we introduced all of them today, I think this first section just focuses in on quadrant 1. If I look at quadrant 1, all of my coordinates inside, or my numbers, should all be what kind of numbers? Positive, right? Because to the right and up are both positive, and so every single number in all of our ordered pairs should be positive today. So in this first problem, where do I go to put K? What? Over 3 and? Up 4. So I come over here, and again, this is where the numbers come into play. Okay, so I look for 3, then I go up to 4, I see where my two figures would connect, and I put a dot. And then I come back, and I put a capital K. So then the last thing we could say is, what quadrant is it in? And you would say, 1. I. Where do I go for 0, 2? Huh? Up 2. Go up 2 and put a B. Last one, 5, 3. Where do I go?
5.
Right 5.
Up 3.
Up 3. Put a D. So again now, when we talked about the origin, what would the coordinates be for the origin? 0, 0. Exactly right. So we're always starting at that that origin, which is 0, 0. Okay? Makes sense? Again, have you talked about this before?
Yes.
Yes? Perfect. So then, another way that we could do it is they could actually give me a point and a letter, and they could say, what is Z? Okay, so again, remember, we're now trying to write what Z is. So again, I'm looking for an ordered pair. So all I'm doing is counting, but again, remember, I always want to go which way first? Right or left, right? So, right, how many? 8, and then up 7, so my answer is 8, 7. Make sense? Okay, how about this one? Let's call it M. What is M? 3, 9, right? 3, up, 9. Okay, so again, M is 3, 9. All right? Pretty simple stuff, hopefully. But again, we'll use this a lot. We'll get into graphing, and you'll have to graph things on this coordinate plane. That's when it gets fun. Some people think it's fun. Like weird people like me think that's fun. Okay. The last thing that's in this section is something called a relation. What's a relation to you? What does that word mean? If you have a relation with somebody or something, what do?
Like your family.
Okay, yeah, your family or something. They go together, right? To do something. That's what a relation is, okay? So a relation is a set of ordered pairs. And whenever you hear the word set from here on out, that means you're going to have something in these weird parentheses. And for whatever reason, people don't like to draw those. So if you just put parentheses, that's all right, but that's what a set should really be. Okay. And then, for our sake today, there should be numbers in there. Or ordered pairs. So we'd have a bunch of ordered pairs in there. So in a relation now, would you agree that each one of these would have an x value in each ordered pair? Okay? So when we start talking about relations, we're going to talk about values of x, and we're going to talk about the values of y. All of the values of x in a set, okay? The values of x make up the domain. Ever heard the word domain? So anytime somebody says, hey, what's the domain of that graph? Or what's that domain of that relation? You're simply looking at all the x values in the problem. Okay? And then I would list them as a set. So in our example right here, I would make another set, and I would ask you, what is the domain of this? And you would tell me what? 4, 5, 6. Exactly right. So if the x's are the domain, the y's have to have a name too. Any idea what the y's name are? All of the y's are called the... Any idea? No idea? So the y's make up the range. The y's make up the range. And again, I'm going to write this as a set. So what is my range for this particular case?
2, 3, 4.
2, 3, 4. Okay. Now, if for some reason you would have a set where there was multiple ordered pairs that had a 4 in it for the x, you only have to write 4 once if you want. You don't have to write the things that happen twice down. You can if you want. You'd never get it counted wrong, but you don't have to. Okay. So when we talk about a relation now, we can do a relation as ordered pairs. We can also write relations as a table. Okay? What's a table to you? What does that mean? Well, a table, if I wanted to take this relation right here and write it as a table, I can write a table either vertically or horizontally. That's basically kind of up to you, whichever one you like the best. I'm not going to really tell you how to do it. If I make a table though, I'm going to probably do it this way, because then when I write my x and y, they still kind of look like ordered pairs. I can do it this way, but again, when I make that table right there, that doesn't really look like an ordered pair to me, and it kind of confuses people which one should come first. So I'm going to usually do it this way, and then as my table, I'm just going to write it as 4, 2, all of my ordered pairs in a table. Okay. So I can do it as ordered pairs, I can do it as a table, or I can make a relation as a graph. So I can take all of my ordered pairs and plot all of my points and then connect them. So again, if I came back over here This would be one time that you would have points maybe on your graph, but you wouldn't necessarily have letters on them, or you wouldn't name them necessarily. Okay? So if I took this set of ordered pairs again and I asked you to graph them, where would you go for each one? Where do I go for 4, 2? Right, 4, up 2. Next one?
5, 3.
Over 5, up 3. And the last one?
Over 6, up 4.
Perfect. And then I would get a ruler, if I'm going to do it as a graph. Now, in this case right here, they might just ask you to plot the points. It might not be a line. So here, this could just be my answer. If they ask you to actually plot the points and graph it, then you would connect those dots. So a relation could be that. All right? That make sense? Any questions with any of that stuff? A lot of information if you hadn't heard about it before, right? So if I look at this one right up here, and I asked you, what is the domain for that relation, what would you say? 2, 0, and 5. And again, put it inside those brackets. If you can't make the swirly brackets, just put it inside any kind of brackets. What is my range?
5, 2,
5, 2, 5, or I could just say 2 and 5. That's it. Easy enough, right? And then if they ask you to write it as a table or a graph, you just go back and you do it again. Okay? How about this one down here? What is my range?
6, 4, 2, 6.
6, 4, 2, and 1, right? The range is my y's. I switched it up on you. All right? Okay. Last but not least, story problem. We all love story problems, right? This is for Alex, even though he's not here. So, Austin earns $5 per hour mowing. Let X represent the number of hours worked. Make a table to show how much he earns for 1, 2, 3, 4, or 5 hours. Okay? So, if he works 1 hour, how much money does he make? $5, right? So, how would I write that or graph that on my chart? If the number of hours is X, so the X is my green axis or going across this way, right? So if I work 1 hour, I make how much money? $5. If I work 2 hours, $10. If I work 3 hours, it's up on the wall, right? Okay? But this would be one that you might want to connect the dots, because if I connected the dots and extended my line farther and farther, it would tell me how much money I would make for each one of those hours. Agreed? And it'd even show me after 5 hours. So in some day, if he worked an 8-hour shift, mowing all day Saturday, we could figure out by looking at our graph how much that he would actually make. Now this one's not very hard anyway. We would know that he made $40 just like that anyway. But that's what a graph could be used for. Okay? If you're going to do something like this right here, when you make your coordinate plane and you're going to plot that stuff, I would write down what each axis stands for. So in this case right here, my x-axis stood for what? In my example here. What did the x mean? Yeah, so when you do this on your piece of paper, I'd come over here and write number of hours. And then, what did my y mean? Money, right? Or how much I made or something. But go ahead and start labeling your axes so everybody knows what it is. Mr. Alish would come in and look at your paper. He would say, oh, okay, this is what it means, right? Okay. Questions? All right. So, tomorrow,